All right, ladies and gentlemen, it's time for your next installment of Number Corner. Aren't you excited? I know I am. So for us to do this, you are going to need this document. That is our May Number Corner calendar about area and fractions. You may have printed this off and be writing it. You may be using it as a digital document. If you're using it as a digital document, you can see I've already discerned a pattern. And because I can cut and paste, it makes things a little bit quicker and easier to manage. I might recommend getting a digital copy of this if you're still trying to write it down. But again, that's entirely up to you. Let's go check out that calendar. This is our total calendar for the month of May so far. We are going to start on the 5th of May. If we look at the 5th of May right here, you'll notice that it is a shape that is the same size it's always been. It's 4 by 6, so that's going to be 24 squares. We've already got that filled out. What we really want to look at is how this is partitioned as an irregular how this is built as an irregular polygon by the shaded parts. How are we going to change this to calculate the area? What you will notice about this is that the shaded part is an irregular polygon. And as a result, we're going to have to partition this into smaller parts. Let's look at how to do that. Okay, that's good enough. All right, ladies and gentlemen, we've taken this square and we've partitioned it into two parts. We have in this one a 3 by 4, that's the yellow square, 3 by 4, and a 2 by 3, that's the red one, 2 by 3. 2 by 3 is 2 times 3. There is 1, 2, 3, 4, 5, 6. There are 6 there altogether. 3 times 4 is going to be 3, 6, 9, 12. There's going to be 12 there. To calculate the total perimeter, we've got to do 6 plus 12. All right, ladies and gentlemen, we can see that we have the area of the colored region as two small partitioned squares, a 2 by 3 square, which is a total of 6 square units, and a 4 by 3 square, which is a total of 12 square units. 6 plus 12 is going to give us our total color area of the colored region as 18 square units. To check that, we just have to count. 12, 13, 14, 15, 16, 17, 18. Now let's talk about the fraction that's shown here. So what fraction is filled? Well, it's 18 out. There's 18 colored. There's a total of 24 altogether. So we've got 18 out of 24. What we're doing on this one is we are going to try to simplify this fraction. That means that we're going to have it be an equivalent fraction, but with lower values. We often have looked at finding equivalent fractions using multiplication. It's super easy. What we're looking at when we simplify is finding an equivalent fraction with division. So what you need is a common factor, a number that can be multiplied to make 18, and the same number needs to be multiplied to make 24. So what will 24 and 18 both divide into evenly? Well, they have a few common factors. One of them is 2. I can easily divide both these numbers by 2 because they are both even numbers. 18 divided by 2 is 9, while 24 divided by 2 is 12. I'm left with 9/12. Now the question is, can I simplify this fraction further by dividing it by another factor? Does 9 and 12 have a common factor? They absolutely do. 9 and 12 are both divisible by the number 3. 3 times 3 makes 9, and 3 times 4 makes 12. So if I take both those numbers, divide the numerator and the denominator by 3, I end up with 9 divided by 3, which is 3, and 12 divided by 3, which is 4. Now, I know I cannot simplify this fraction any further because 3 and 4 do not have a common factor, with the exception of the number 1. 1 is a common factor for every number. Every number can be divided by 1, but if I divide 3 by 1, I end up with 3, and if I divide 4 by 1, I end up with 4. That is 3/4. So 8/12 is equivalent to 9/12. Oh, I said that wrong. 8/24 is equivalent to 9/12, which is equivalent to 3/4. Let's look at the next day of our calendar. This day, we have our shape has been split up into 3 equal parts. Only the center has been shaded. What is the area of that center portion? Well, it's 2 on the bottom and 4 on the side, so it's 2 by 4. So I got a 2 by 4 array. My total area of the color region is going to be 8 because it's 2 times 4. We know the color was green. Then we're looking at the fractions. Again, we're going to try to simplify this fraction by dividing it by a factor, a common factor. What do 8 and 12 both divide evenly into? I can get to 8 by multiplying by 2, multiplying by 4, and multiplying by 8. I can get to 12 by multiplying by 2, multiplying by 3, multiplying by 4, multiplying by 6, and multiplying by 12. What factor did they both have in common? Well, they both had the 2, so I can divide it by 2. 8 divided by 2 is 4, and 12 divided by 2 was 6. I end up with the fraction 4/6. I could divide 4 and 6 by another common factor, which is going to be 2, which is going to end up with 2/3. Alternatively, I did not need to stop at 4/6 in between. I could have simplified 8/12 to its lowest value, 2/3, by dividing it by one number. What number would I divide that by? It would be 4. 8 divided by 4 equals 2. Alternatively, 12 divided by 4 makes 3. 8/12 is equivalent to 2/3 and is also equivalent to 4/6. We simplified it by finding a common factor. Let's look at the next day. On May 7th, that was Thursday, we had 4 on one side and 4 on the other side. This makes a square. That's called a squared number. So we had 4 times 4 equals 16. Now I call this a squared number because anytime that you multiply a number by itself, that's called squaring the number. We have 2 squared numbers on here. We get the number 4, which is 2 times 2. So 2 squared is 4. And then we've got 16. 4 times 4. 4 squared is 16. You might even have people say, what's the square root of? That is when you divide that number by a number that it can be the square root of. These are the square roots. What's the square root of 16? Well, it's 4. What's the square root of 4? It's 2. All that's information you don't need to know for 3rd grade, but it's nice to have extra stuff. What you should be looking at and what you do need to know is about fractions and factors. So I've got 16 out of 24 for this one. What can I simplify 16 24ths into? I got to look at a number that both 16 and 24 divide evenly into. Now, they're even numbers, so it's definitely going to be 2. But it's not just 2. Those 2 are factors of a whole bunch of other numbers. To make 16, you can multiply by 8. You can multiply by 2. You can multiply by 4. You can multiply by 16. To make 24, you can multiply by 2, you can multiply by 3, you can multiply by 4, you can multiply by 6, you can multiply by 8, you can multiply by 12, you can multiply by 24. What factors did they have in common? Well, they had 4. Let's work with 4. What is 16 divided by 4? Well, we looked over here, we know that that is 4. Then what is 24 divided by 4? Well, that's 6. Can I further simplify 4/6? I sure can. They're both even numbers. I can divide both of those by 2. 4 divided by 2 is 2, and 6 divided by 2 is 3. 16 24ths is equivalent to 4/6, which is equivalent to 2/3, which is equivalent to the fractions we had yesterday on the 6th. Last one to look at is today, the 8th. Now this one you have not seen yet. We are going to flip the 8th, the 9th, and the 10th. And we're going to check those up on Monday. So the 8th looks like that. You get the same size shape. 4 by 6. One portion is shaded, but this portion is not shaded purple or green. It's an entirely different color. Uh-oh, I might need to readjust my calendar. It's a good thing mine's a digital copy, and that's easy to do neatly. Let's look at the 9th. Hey, May 9th is my birthday, everybody. Whoa, look at that thing. Oh, I love this one. I'm so excited about this one. You have to figure out Not only what is the shape of the size of the entire shape, but what is the area of the shaded portion? I'm going to give you a hint. I would partition this into 3 separate squares. 1, 2, and 3. Calculate the area of all 3 of those, add them together, you'll have your total. Then we've got Sunday the 10th. There's no way this one's going to be as good as the 9th, but let's look at it. It's not nearly as good as the 9th. That's true. You still need to calculate the weird irregular polygon that we have here for the total shape. Before, we had been doing 6 times 4 equals 24. If you extended that all the way down through the bottom of your grid on your Math May calendar chart, you might need to do a lot of erasing unless you used a digital copy, and then you can easily just delete. You've got to calculate the area of this small portion right here. Hey, that's pretty easy. We'll look at the 11th on Monday. 'Cause on Monday, we're going to update those and introduce the next ones. Have a great afternoon, everybody.